Good morning, good afternoon, and good evening, everybody. Welcome to another Kemp Flowmon webinar. And today the topic is 4 key application experience monitoring technologies that you cannot ignore. So this is going to be a great conversation where they're going to be talking about some really cool technologies and what it can do to help you with your network environment. And to start things off, number one, some housekeeping things. This webinar will be recorded, so it'll be available on demand. And please, if you have any questions throughout this thing, please go to the Q&A section and put in your question. And at the end of the session, when we have time, we will certainly answer as many questions as we can. My name is Frank Yu. I'm the Principal Application Experience Architect for Kemp Technologies, and I have a great special guest with me today. We have Philip Cherney, and I know I don't get the name exactly right because Czech pronunciation doesn't exist in American English. So I apologize, Philip. But Philip is our senior product marketing specialist for the Flowmon technology side of the fence. And Philip, tell us a little bit about yourself.
Yes, thank you, Frank. And don't worry about the pronunciation. You completely nailed it. So thank you for the introduction. As Frank said, hello, everyone. My name is Philip Cherney. I'm part of the product marketing team for Kemp. And I've been with Kemp and Kemp Flowmon company for the last 6 years. My background goes in sales, now in product marketing. And I'm a huge enthusiastic into basketball and recently also in beach volleyball. So I really am excited about the nice weather today, and I can't wait to really do some exercises afterwards. But anyway, let's get into this because we have really some nice things to talk about.
Awesome. Basketball and beach volleyball. I know for a fact that I'm bad at those I'm not a very tall person. And I think my coordination skills aren't quite where yours are. So I applaud you for doing those things. And I wish I had the athletic skills and ability to do those things. So let's get to this presentation. 4 key application experience monitoring technologies that you cannot ignore. And these really are key concepts and things that we want to talk about that's going to be important for you because application experience monitoring, it's an important subject. We complain and talk about it all the time in various forms, but we often think of it as an afterthought, something that we have to do after we build. So we design and build and create these cool things, and then we're like, oh, we need to monitor this as well. What have we done? And this is a stat from Gartner, analyst firm. 54% of HR leaders indicate that poor technology and or infrastructure for remote working is the biggest barrier to effective remote work. And I can extend this concept across to not just remote working, but working in general in these IT environments and infrastructure. And the problem is not really and truly that the technology is poor, because there's great technology out there. The problem is that we don't really understand how and what we're building from an operational perspective. We need the insight to understand how these things are performing. And so we don't optimize what we build for the applications that we have because we don't really understand, we don't have that visibility. And this is a big thing that we need to do to really get to where we want to be, at least visually, and in terms of this nirvana of what we picture in our mind when we start building to where we are today. And a big problem is that there's lots of different points to consider, not different teams in terms of technologies. So we have the application servers, we have the people that write the code, we have the network infrastructure people, the nuts and bolts people, the switches and the routers. We have the security people with the firewalls and the IPS and all these other technologies, the web application firewall. We have all this stuff out there, and we don't coordinate these organizations very well. And we're going to hear that more as we continue talking. How can we do things to help coordinate these different teams and organizations and technologies to really get that optimal experience? But it's very hard to pinpoint that it's their fault or it's his fault or her fault in terms of why it is not, our infrastructure is not doing what it's supposed to do at any given day. So application experience is this concept that is really important for us. It's kind of hard to quantify because I can't give you nuts and bolts to say, if you do X, you will get this thing called application experience, or you will get the optimal version, or there's no numbers, but there's a lot of different metrics and things, and it's very qualitative. So one way to define application experience is the user reaction to their interaction with digital applications. In other words, it's the user's experience with the application, with this digital thing, because as we know, digital transformation, all these things that we've been doing, everything is moving to this hybrid world, to this digital world where everything is run through applications, where it used to be pen and paper, brick and mortar, me going in person to do things. Now I use applications, apps on my phone, apps on my laptop, apps on various things. Even when I do go into stores, for example, there's still a lot of apps. I can pay, for example, with Apple Pay or Google Pay or other various types of things with applications. I can pre order things through applications when I go into the restaurants now. There's so much stuff that's done digitally. And this experience, this an interaction with the customer of the application, and that could be an employee, that could be a customer in terms of retail. You have to give them the proper experience, because if they don't have a good experience, what are they going to do? They're going to walk away. So we need to define and determine what that optimal experience is to really get this concept of delivering this digital transformation and really getting this AX, optimal AX for our environments. And again, these environments that we're dealing with, they are really complicated today. They're complicated because they have lots of different pieces. Excuse me. Where we have, you can see in this little high level diagram, we have applications on the right hand side. They could be in our data center, where I have servers, I have applications, I have my load balancer in the diagram, of course. And on the left hand side, we have things in cloud. This could be public cloud like Amazon AWS, Microsoft Azure, Google Cloud, IBM Cloud, third-party clouds, etc. And it could be private cloud also, software-defined data center, where I'm using virtualization technologies to create my own cloud-like infrastructure like VMware or Microsoft Hyper-V for hypervisors, and other pieces to really SDN technology, software-defined networking technologies. And this is all going through some sort of intranet cloud in the center and going to the user. And the problem is now also the user is not well defined. I could be connecting to these applications through my phone. I could be doing it on my phone through Wi-Fi or through a cellular connection. Just before we started this webinar, I was talking to Philip, and he was checking his connection on Wi-Fi versus using a cellular hotspot to determine which one was better to get his optimal application experience. I could be doing it on a laptop, on a desktop, who knows what. We don't know the devices. It could be an IoT device that's going through this thing, where it's kind of this automated thing doing it as well. But these network environments definitely complicated, and it makes it hard for us then to understand what is the application doing, what is the user doing, and how do we monitor and manage that experience with all these little complex elements. So really what we need to do is create this real-time application performance monitoring, this concept of APM, application performance monitoring. And it needs to be real-time because we need to know about things happening when they happen. And we do this to optimize that user experience and ensure SLA, so service level agreement. And this is an important point I always like to say. SLA. How many of you listening to this have SLAs currently defined for your applications in terms of, is the application performing okay? Is it not performing okay? And I'm going to suspect, because this is what I've seen historically, that a lot of you don't have SLAs predefined and written down for your applications. And then the question becomes, Well, how do you know an application is performing poorly if you don't have an SLA? So this is an important step for you to understand application performance monitoring, is to understand what isn't good and bad for you for these existing applications, and then to start creating thresholds and criteria on when these SLAs are being met or not. We want to have these application delays to be the delays in the application to be reduced, and we want the troubleshooting to be reduced in terms of how complex it is, how long it takes, and going in the right direction, understanding and getting to this root cause of the problems. Because ultimately, all this by doing this monitoring and this reactive response is going to ensure that satisfaction with the application. If I don't like an application, I'm going to go somewhere else. I'm going to shop somewhere else. I'm going to go to a different store because they give me a better experience. So we want to ensure that these customers' employees have that proper satisfaction. And this is how we build that and manage that. And to do that, we really need this next generation network traffic monitoring network traffic and performance monitoring to get the insight into what is going on with the infrastructure. We want that visibility, and this is an important point. We want visibility into the network traffic. And when I say network traffic, I don't just mean bits and bytes in terms of we have 10 megabytes or 10 megabits per second going through this interface, and my WAN utilization is at 80%. I want details about the applications, because it's the application that matters. So I need to understand more about application-centric details, because some metrics might look good and others will look bad because of this, and we'll talk about this. And by getting this visibility, we're going to reduce that mean time to resolution, the MTTR. And we're going to increase the efficiency of our organization, because it's going to make it easier for us to troubleshoot, easy for us to fix. And what this is, in turn, is going to reduce that downtime, reduce network operational costs, and really and truly, I'm kind of scared to say it, but it's very true. We can start being proactive instead of reactive in terms of our operations, because we start seeing the problems before they reach a tipping point in terms of people complaining or reaching SLAs. So we can see things before they reach that critical point and start adjusting based on that, so that we can actually fix things before they actually really break. And that's a really cool concept for us to consider. So at this point, I want us to go through this presentation and turn it over to Philip. Philip has some great info talking about these 4 technologies that we're going to be discussing for this end user experience, for monitoring this and monitoring and optimizing the application experience. So Philip, I'm going to pass it to you and let you take it away.
Excellent. Thank you very much, Frank. So let's jump right into this. So what are the 4 key technologies that we can use or think of when we want to measure the application experience? So these are the 4 technologies that we will look at. We will look at their pros, their cons, what is the typical use case, and what are the benefits. So the first approach we can use is the infrastructure monitoring. So what is infrastructure monitoring? We can see on this nice screen, infrastructure monitoring is not necessarily used to measure the application experience, but more overall health and availability of the application. So on the screenshot, we have actually a print screen from the solution called PRTG from our technology partner, Paisler. And what infrastructure monitoring does is give you the data that you can see the health or status of each components in the network, like router, switch, or server. You can see the overall traffic running through the active devices, and basically what is the CPU usage, how big is what is the usage of the memory, and it will give you the overall health of the devices in the network. But that doesn't tell you if the user on the other end of the application is experiencing some issue, if there is a latency or etc. So I don't want to say this doesn't mean that infrastructure monitoring is useless. It doesn't have its place in the network tool set, and it is very useful, and it's a very complementary tool for network visibility. But it doesn't provide the application performance monitoring for the real user experience. I would say that this solution is a first step you should start with before you jump into more deep network and application analysis. So now, on the other hand, in order to be able to debug application and actually see where are problems in the application and user experience and users are experiencing problems, is to use agents. So this is a very traditional approach for application departments to tackle and understand the behavior of the application. So the benefits of this approach is that you have deep visibility across all applications. You can see different levels of the application, each transactions, what is the latency, and you can measure the real user experience. This solution is often used for critical application. I would say this is like a very heavyweight solution. So, for example, if you are an application developer and you want to troubleshoot performance of the application with a real traffic for real users and in real time, then this is a great solution. But given how robust the technology is and the and resources needed, and not to mention how financially demanding the solution can be, it's most likely not scalable to use for monitoring for all your third-party applications that your company uses and really scales across hybrid environment. So this solution is complicated to deploy, but it has its value, definitely. But I would say it's not for all the application. It's only for the critical applications. And there are different approaches that we will now look at that might be more suitable than this. So in some small cases, this solution can turn out to be an overkill. So the third approach is syntactic testing. So this is actually a print screen from our solution. So this is where I start a little bit of the promotion and tell you how this works. So syntactic testing is nothing more complicated than just running a script through the application with defined route, basically how would an user behave in the application. So let's have a real example. For example, if you create a scenario that you are a bank and you want to check how the user would go through the application of the internet banking. So for example, you want to first sign into your account, you want to check the balances. From balances, you would want to check your payments, and then you would want to log out. So this is a defined path that you would basically define and run the script on this application. And the script will run through the application and can tell you, for example, if everything runs smoothly, how long did it take, was there any problem, was there latency? And for example, if there would be a failure, you can see, I hope it's visible enough in the slides, but you can see 2 green lines, and then the third line in the picture is red. So that means that the third step of this defined path, there was a failure. And you can even, at the button, click to see the screenshot, and you can see how the user would view that exact transaction. So in this example, this is actually a script that is testing our website. And let's have a look how it would look if there was no troubles. So there are 4 green lines in the picture, all green. We can see on the right the duration of each transaction, of each click, and it was all green. There was a success, and we can see now the difference, how the web page was supposed to be correctly viewed to the user. So, excuse me. So I would say this is not a rocket science on its own, but having this solution together with network analysis and application performance monitoring together and seeing all the information in one context is where this solution has its value. So coming away from the syntactic testing and diving a little bit deep into network analysis that I just mentioned. So network analysis is a different approach to measure application performance and network latency. It's done from the perspective of the network, where we measure communication and traffic between users and application. And by measuring some critical timestamps in that conversation, we are able to measure the differences between application and network delay. So there are actually 2 ways how this solution can be implemented. One is more general, which can be applied to any web application, regardless whether you own it, run it, or deliver it or not. The other is more deeper, that goes into the level of actual user transaction and clicks that you would use for your critical application that you own and want to troubleshoot more deeply. So I have prepared 2 use cases where we will see the value of those 2 approaches. So let's have a look at it now. This is a really nice slide, and Frank, I think you would agree with me that I doubt there is a person in the IT industry who would not relate to these pictures. So if there is a problem in the application and user complains about the application being slow, what tends to happen? It goes to the support, and then on the other hand is someone who needs to figure out where is the problem. And then this is like a typical game that always happens. We call it hot potato. So basically, is the problem in the network? Is the problem in the server? Or there can be a problem that the user is running too many apps on his computer, so it can be a problem with the user. And usually what we encounter on the market and with our customers is that network department has its own sets of tools where all they can see is green lights. So their first response will be, the problem is not on our end, the problem must be on the server, on the application. So let's give this to the application department. And application department team will say exactly the same thing. We have no problem here. We can see green lights everywhere. The problem must be on the user's end. His internet connectivity is too slow. And what it results in is that the user is really unhappy because the problem wasn't solved. And he is most likely to share his negative experience on the social media, which is in the end has the final impact, negative impact on your business that you try to run. So let's have a look at the first network analysis use case. In this case, the slow internet connection. So what happened here was exactly what I just mentioned before. So an user was calling, complaining that the application is running too slow. He cannot do any of the work. Please, IT administrator, do your magic. Can you help me? So in this case, if the IT administrator is monitoring the network traffic, he can then see this view and check, okay, we can see that the traffic is really saturated. Let's see where the traffic is coming from. And you can then drill down into this. You can then select the specific peak of the traffic, which we can see on the top left corner. And so, for example, view top 10 statistic of the IP conversation. So basically asking, where is the traffic coming from? And on the picture on the right, we can see on the graph that basically the blue portion is taking most of the bandwidth. So Akamai means Windows update. So what is the target host? And we can check the drill down, and we can see that these first 10 IP addresses, local computers, were downloading Windows update, but not from the local WSUS server. So basically, they were those 10 computers, because of improper configuration, were slowing down the internet connectivity for the entire company. So a relatively an easy case to solve if you have this sort of solution and you have the way to see where is the problem. But if you would not monitor the network traffic, solving this problem could take from hours to days, which is where the application experience is becoming unbearable, because you cannot wait hours for the app to start working again. So in this case, this was the more general approach where you monitor network traffic, and it turns out the problem was on the network side. Let's have a look on another use case where, as it might suggest, the problem will be on the other end. So this is a use case from our customer, Oborová zdravotní pojišťovna from Czech Republic. And what they experienced was a problem with their with their applications for their clients. So this is a health insurance company, and they created applications where their clients can log in and see their entire health history and historical data. And they were receiving complaints for several weeks. I think it took 2 or 3 months, that the app is really too slow to load. It takes forever. There are error codes. Basically, the app doesn't work. And as I mentioned the scenario on those 2 slides ago, exactly what happened was the typical blame game, as I like to call it, between the network department and application department, basically complaining on each other that we have the green lights everywhere, there is no problem on our end, so it must be the other team. And in the end, users were sharing negative experience on the social media, which was heavily impacting the business. But if you would monitor the applications with network analysis, you can then check the real user experience for different parts of the applications. So, for example, in this example, we can see that if the user would click to client profile, you would see that all of the transactions were answered within the SLA, so everything was running smoothly. But if you want to click from client profile to health diary, you can see that half of all the transactions were out of the SLA, which means that the page did not load, so the application did not work. What's also useful to mention that with this network analysis approach and application performance monitoring, you could also provide a detailed report with error codes. So what kind of error codes, how many times they occurred, which part of the application it was. So all together, this all provided a really detailed report to the customer, who can then come to the third-party application developers and tell them exactly with the proof, we are paying for this application to run smoothly, but it does not run. You are saying us that it's run smoothly, that you have green lights everywhere, but here is the proof. Here is the proof that the application doesn't work as it should. So please fix it. So Those were the two approaches. In the end, I would like to share the application experience troubleshooting checklist. So basically, what kind of questions you should ask to be aware if the application is running smoothly. So which user experience the worst application's responses, which transactions return error codes, how severe is the impact of remote access, which is something that is on the rise because of the whole global situation today. What are the relationships between users and banned transaction, and etc. So to summarize, there are really a couple of approaches you can take to monitor the application experience. I think we mentioned what are the pros and cons or these different approaches. And Frank, with this, I'll give the world to you. And
Awesome.
you can take it from here. Thank you.
Thank you very much, Philip. That was extremely informative and a great walkthrough of these different scenarios and how these different technologies can help us with monitoring application experience, monitoring these applications, really deciding what makes sense. So, in a summary, the key thing for me is that these four technologies, the infrastructure monitoring, the agents, which are basically telemetry sources, the synthetic testing, that's this network analysis, they're all pieces of a big puzzle. Excuse me. And we need to incorporate all of these tools, or as many tools as possible, into one nice single holistic framework so that we don't have to look at 10 different dashboards and interfaces and create things, but get one system that can take these different pieces of information, whether it's the agents getting this application level experience, or there is infrastructure monitoring telling us if things are up or down or green or red, but give us that big picture, and the big picture then ultimately at the application level, because it's all about the application. It's all about, is my Outlook working right? Is my HR app working right? Is my e-commerce portal working and giving our users the best experience? So incorporating all these things and all these technologies into a single framework, into a unified framework, we can do things like improve productivity. We can improve productivity internally for the company employees. Obviously, I think by having things work more efficiently, people being happier using the application, and also externally. So we're going to generate better revenue for e-commerce sites and for customer interactions if you are a retail business, because they're going to have a better experience. They're going to get through the application or the website faster, and it's just going to be a great thing. And that obviously translates to avoiding customer churn. In other words, the customers are not going to walk away because of an unhappy experience. I've done that personally many times, where even though I like the product, I didn't like the experience. So I'm going to walk away from that business and find somewhere else where my experience is more appropriate. And internally, that obviously makes a lot of sense. I mean, if I don't like using the application that the business is forcing me to use, then obviously I'm going to find other ways to get something done and to avoid using that application. We need to have that optimal application experience and optimal application environment. And we can't have that if we're not using these tools and these technologies that we discussed to make it happen. And of course, again, these all translate into moving into each other, minimize business impact. I mean, if I'm not using the application that I'm supposed to be using as an employee, that's going to impact the business. And we need to change things so that we minimize that impact and improve that application experience. And obviously, on a retail perspective, again, I'll use e-commerce as my example. If users are having a happy or optimal application experience, they're going to be using the website more, they're going to be buying more things, and it's going to be obviously generating revenue. Taking back control of decentralized IT, this is a big thing, and we kind of alluded to it. We didn't really go into detail on it, but we alluded to it with these different organizations. We had the server guys and the network guys. guys and gals, I should say. And this is something I've experienced over my entire career. Philip, you mentioned that you have as well. And I'm sure everybody else in the IT industry, if you work in IT, you've had the same problem where the network people and the server people are like, I like using the example, and I apologize if you're not American, but I'm going to say it's like the New York Yankees and the New York Mets. You're one or the other, and God forbid if you're the other. We just don't talk to each other, and it's always your fault. And that's how the network and server people tend to be, just historically. And this is true for all of these different organizations that we've created in our IT world. So when we talk about DevOps, and we talk about these DevOps developers, and now we have them in the QA and the pre-production and the security folks and everything. And again, there's a lot clashing, and this creates this environment for this decentralized IT, because everybody's kind of doing their own thing and not listening to everybody else, and there's no corporate standard that everybody follows, or there is, but they don't follow it. So being able to create a single view that crosses all these different organizations and environments and gives them all insight from a single point is huge to bringing them together. Just like Philip said in his example, user calls about a problem and it gets thrown around like a hot potato between the organizations because nobody will take responsibility. It's not my problem until you prove it's my problem. It's the general gist of what happens. But if we have one view that translates and goes across these different organizations, we can all look at the same view and say, yes, we understand, and it goes here. And we will work together because we're all looking at the same thing. This is huge to bringing IT organizations together by providing this unified perspective of management and monitoring of your IT infrastructure and your application experience. And of course, we've talked about it. Fast time to value. We want something that responds and reacts quickly and provides value very quickly. So we want to know about problems when they happen, or maybe even before they happen, because we're learning before from the metrics. And we want something that can be easy to use, deploy, and get up and running. So we can have deployment to data within 30 minutes, for example, with the Kemp Flowmon solution. So we want something that can give you value and give you a proper responsiveness with these technologies and incorporating all these components of these technologies. Bringing all this together is what we're trying to do and what we want everybody to do in terms of using these technologies, these 4 key technologies, and bringing them together for this application experience and monitoring and managing the application experience for our customers. So ultimately, I mean, if you're interested in learning more, the really great thing is you can go, I have a link here, kemp.ax/network-assessment-trial. Go to the webpage and you can get a free network assessment from the Kemp Flowmon experts. We will go in, we will go work with you to identify what your network looks like and how it is performing, to give you a snapshot of what is happening and give you an understanding of what you can do with this technology. And I can tell you, it is eye-opening to have this network assessment done. It is eye-opening to be able to see what is happening on your network if you haven't done so with some really good tools. So I strongly recommend, if you haven't done so, take a look at this free network assessment. No charge, no pressure. Well, maybe a little pressure because they are salespeople, but it's a good experience and good process for you to go through. And if you have any other questions, of course, you can contact us at sales@flowmon.com as well. So please reach out to us, get more information. In the meantime, Philip, let's go and take a look at some of these questions that we have here.
Yes.
So Philip, I have the first question here. And the question is, does the solution run in VMware? And I think that we can expand on that. I mean, Can you tell us what platforms and what environments this type of solution, like the Kemp Flowmon solution, can run in?
Yes, of course. So the quick answer would be yes. The solution can be deployed either as a hardware appliance or in a virtual environment. We support all the major players: Hyper-V, KVM, and VMware.
Awesome. So if I'm running in a virtualized environment and I have my software-defined data center, or if I'm even in a public cloud, then I can deploy this environment in software. Or like you said, you mentioned we have hardware appliances, and I'm assuming the hardware appliances can provide a much better performance model than the
Yeah.
software versions.
Yes, definitely. We usually recommend, if you have a network with 10 gig environment or higher speeds, to go with hardware appliance, because this is where we guarantee the performance will work. With virtualization, there can always be some tricky problems, but yes, both virtual and hardware appliances are available.
Awesome. That makes a lot of sense. And here's a second question, and it goes in line with what we were just talking about, where I just mentioned, we can throw things in the clouds. What about applications that I have in the cloud? If I'm putting my applications in public cloud like AWS or Microsoft Azure, can we monitor these applications like we would all these other things that we talked about in this presentation?
Yes, you can monitor them exactly the same way as you would monitor your your applications in your on-premise environment. So we support the Google Cloud, AWS, and Microsoft Azure, and all we need to just mirror the traffic from the application server hosted in the public cloud, and we can provide the application performance monitoring and measure the user experience.
Awesome. And to extend on that, then, if I have an application that's in I'm going to say in a hybrid environment where I have on-prem, I might be doing cloud bursting. And for example, in AWS, I might have multiple data centers in different regions. I can monitor all these different components and still get a single kind of view of how my application is performing through these tools.
Yes. So if I go a little bit deep into the solution, what you need to do is deploy the Kemp Flowmon probe, or like a sensor, close to the application server, which will mirror the traffic and sends it to our Kemp Flowmon collector. And this is one centralized. This is where you analyze the traffic, the data. It shows with one centralized dashboard. You can see each application with each transaction. You can create your customized reports, customized dashboards, and everything. So yes, you will have one centralized view of how the application is performing.
Awesome. That sounds great. And that makes a lot of sense, because that's what we want. We want that unified application viewpoint, right? We want that unified system to give us that view, that application experience, so we can monitor things properly.
Yes. Yes, sorry, Frank. I was just going to build up on that and say it actually tackles the problem that we've already talked about, the network people versus application department, and giving them the one unified view so they can both use one tool to see where the problem is.
Awesome. And again, that is the internal people issue with IT organizations and management of things is such a big piece that people don't think about. But there are things we can do, like using technologies like this, that can help bridge that gap from the people issues to the technology issues. So that's awesome. So I have another question here. What types of data sources does the solution work with?
Great question. So the whole solution is based on flow statistics like IPFix or any kind of flow data. So in the first example, we mentioned the general approach to where you can monitor the network traffic. And this is basically what I already mentioned. You can have Kemp Flowmon probe, like a sensors deployed all across your environment, to capture the full traffic and generate this IPFix data, this network telemetry data. and send it and feed it to the collector. We can also collect the data from your current infrastructure. So if your router or switch can generate the flow data, whether it is Netflow version 5, Netflow version 9, S-flow, J-flow, any kind of flow with the right amount of information, we can feed it to the collector from multiple sources and provide you the centralized dashboard with all the data for deeper analysis.
Awesome. And to clarify for people listening, if you don't understand, IPFix is a protocol, is an open standard protocol that's been ratified for this flow data, for how this data is formed and sent from various devices. And then Philip just mentioned other flow technologies like Netflow. Netflow was created by Cisco. It's kind of like the original flow data technology, created actually back in the 1990s, if you can believe that. And there's Netflow V5, which is kind of the basic standard, and now version 9. And then he also mentioned things like S-flow. S-flow is an interesting technology that's based on sampling. That's an open standard as well. That's publicly available. And J-flow is Juniper's version of the Cisco Netflow. And there's other various flow technologies. But the cool thing is that they're all fairly standard and fairly interoperable in terms of the data that they're sending. So using a Kemp Flowmon collector to collect all these data sources and supporting all these data sources becomes really cool, because now you can collect all these disparate data sources from different technologies, different vendors, different concepts, and still get one nice clean picture in terms of how your application network is performing, even though it's using all these different data information. So I think that's really awesome, taking advantage of those and other pieces.
Definitely agree with you, Frank.
Thank you. Not everybody always agrees with me, and I'll always appreciate it when people do. So I appreciate that. So one more question here, Philip, before we close off. I have one more question.
Okay.
Can this technology be used for small companies, large companies? What is there a minimum size of your network or types of things that you need to do, or is there a maximum size in which this technology can support? Can you give me an idea of what type of companies can leverage this technology and functionality?
Yes, definitely. Great question. I guess it probably came up when I talked about one of the approach that was the agents. So I already mentioned that solution was not scalable, and because of its demanding on resources and everything around that. But what's great about this Kemp Flowmon solution is that it's really scalable. It's suitable for a small company with we say 100 employees, all the way up to big enterprises with thousands, tens of thousands of employees. So the solution is scalable. It only depends on your use case. What kind of applications do you want to monitor? And we can definitely size the right solution to fit your environment exactly.
Awesome. So I love that response, because basically what we're saying is, if you have an IT environment, if you're a business that has an IT environment, and that's 100% of you, that's everybody out there, because you're using technology in some way. You probably have a website, you probably have servers, you probably have applications you're using internally, whether you're a small company or large. No matter what size you are, you should be looking at investigating, if not incorporating, this technology as soon as you can, because there's such huge benefits for you. So
Yes.
awesome. So any last words or things that you want to say before we close here, Philip? I greatly appreciate everything that you said, and this has been a great information that you've given us.
Thank you, Frank. I would just really encourage people to try it. So the previous slide that you showed with the free network assessment that is available from Kemp company, I think this is a great way to start to check without any commitment, free of charge, how is your network and your applications performing. And we're really happy to give you this overview.
Awesome. Thank you again, Philip. Thank you, everybody, for attending. Look forward to more Kemp Flowmon webinars on the Sprite Talk channel. And we look forward to giving you some more really cool content in the future. Again, thank you, everybody, and have a great day.
Thank you, everybody.
Bye.
Bye.